Niacin is increasingly recognized not just as a systemic lipid-lowering agent, but as a cellular guardian that intervenes at one of the earliest and most crucial stages of atherogenesis, the transformation of macrophages into foam cells. Foam cell formation is a defining hallmark of early atherosclerosis, representing the point at which immune surveillance gives way to chronic inflammation and plaque development. This transformation occurs when macrophages engulf oxidized LDL particles and fail to effectively clear the resulting cholesterol load, particularly within lysosomes. The buildup of cholesterol in these organelles overwhelms cellular homeostasis, triggering dysfunction, inflammatory signaling, and eventual cell death. Niacin directly counters this process by enhancing lysosomal cholesterol export, thereby protecting macrophages from becoming foam cells and helping preserve vascular health at its foundation. The mechanism is elegant and highly specific. When niacin is taken up by macrophages, it activates CD38, an enzyme that synthesizes nicotinic acid adenine dinucleotide phosphate, NAP, a potent calcium-releasing second messenger. NAP stimulates lysosomal TRPML1 channels, leading to localized calcium release that triggers the activation of liver X receptor alpha, LXRA. LXRA, in turn, upregulates a suite of genes essential for cholesterol trafficking, namely Niemann-Pick C1, NPC1, ABCA1, and ABCG1. These proteins work in concert to transport cholesterol out of lysosomes and ultimately out of the cell, preventing intracellular accumulation and the cellular reprogramming that leads to foam cell formation. This cholesterol detoxification pathway is critical in the early stages of atherosclerosis, when macrophages are first exposed to lipid-rich environments but still retain their full metabolic capacity. By promoting cholesterol efflux before irreversible damage sets in, niacin preserves macrophage function and forestalls the shift toward inflammation and necrosis. This preventive effect is especially significant because foam cells are not merely markers of disease. They actively contribute to lesion progression by secreting cytokines, attracting more immune cells, and forming the lipid-rich necrotic core that destabilizes plaques. Unlike therapies that intervene later in the disease process, niacin acts upstream, intercepting the very cellular changes that initiate atherosclerosis. Its protective effect is not contingent on changes in plasma LDL or HDL levels, as demonstrated in animal models where niacin reduced foam cell accumulation and plaque formation despite unchanged systemic cholesterol. This indicates that niacin's benefits are primarily driven by its intracellular action, clearing cholesterol from lysosomal danger zones and reestablishing cellular lipid equilibrium. Moreover, niacin's influence is not limited to cholesterol handling. By preventing foam cell formation, it also reduces downstream activation of the NLRP3 inflammasome and secretion of pro-inflammatory cytokines like IL-1S. These inflammatory mediators play a pivotal role in plaque development, recruiting additional immune cells and sustaining a cycle of chronic vascular injury. Niacin's early intervention thus interrupts both the metabolic and immunological drivers of atherosclerosis. Importantly, this protective role occurs without triggering the adverse hepatic effects associated with synthetic LXR agonists. Niacin's activation of LXRA is conditional and tissue-specific, likely because it depends on localized CD38 activity and lipid stress signals, both of which are elevated in atherosclerosis-prone macrophages, but not in healthy hepatocytes. This precision enables niacin to act where it is needed most, without provoking systemic side effects like hepatic steatosis. In summary, niacin's ability to prevent foam cell formation through enhanced lysosomal cholesterol export redefines its role in cardiovascular prevention. It operates at the cellular origin of atherosclerosis, preserving immune cell function, reducing inflammation, and maintaining plaque stability. This early, targeted intervention suggests that niacin is not merely a supplement or a legacy drug. It is a potent, selective modulator of vascular health with the capacity to prevent disease at its earliest and most reversible stages.